All right, we've made it to the end of chapter 3. We're going to be using inverse matrices to solve systems. Reminding you that you should go now do the extra practice in Unit 3. It's been a long chapter, but I think when you go back and do everything, you should feel like you have a pretty good handle on it. I'm hoping. That's why you have to do the extra practice in preparation for the test that you'll have when you return. So, an inverse. How do I find the inverse of a 2 by 2 matrix? This is how I write it, the inverse of A, and that's equal to 1 over the determinant of A times what I like to call the switcheroo matrix. I switch these two guys, D and A, and then I just negative these two guys. They don't change places, they just become negative. And I'm just going to remind you, how do you find the determinant? Well, that's just A times D minus B times C. So suppose I have matrix A, 3, 8, 2, 5. So how do I find the inverse? It's 1 over the determinant, again, which is just 3 times 5, 15, minus 2 times 8, which is 16. 2 plus 8 is 10. And then I'm going to have to multiply whatever that number is by the switcheroo matrix. So I'm going to switch 3 and 5, and I'm simply going to negative 2 and 8. And so this just becomes 1 over negative 1, which is a nice number. And then that's scalar multiplication, this is just negative 1. So when I multiply each element by negative 1, I'm going to get a negative 5, an 8, a 2, and a negative 3. So if A is 3, 8, 2, 5, the inverse of A is negative 5, negative 3, 2, and 8. Now, that might seem a little coincidental, but that's largely because our determinant was negative 1, not too much changed. All right, so how do we go about using the inverse? This is where the cool part comes in. So one of the first things I'm going to tell you is that if I'm talking about matrices and I'm multiplying matrix A by some unknown and I get B, if we wanted to get X by itself, we would divide by A. But you can't divide by a matrix, you have to multiply by its inverse. It's sort of like multiplying by a reciprocal. So if I want to get this unknown, I take the inverse of A and multiply by B. How do we apply that to a linear system? Well, if I have this system, I can write it as a set of matrices where 2, 1, negative 3, 4 would be my matrix A. And if I multiplied that by x, y, I would get 19, negative 7. And think about row by column. That's how we multiplied matrices. So 2 times x plus negative 3 times y would be 19. So now I have matrix A, now I have my unknown matrix, and I get B. So my x will just be the inverse of A times B. So how do I find the inverse of A again? Well, the inverse, so x equals the inverse of A is 1 over the determinant, which is 2 times 4, minus negative 3 times 1, so that would be plus 3. And then multiply that by the switcheroo matrix, 4, 2, negative these guys. And then again, I have to multiply now by matrix B, which in this case is just 19, negative 7. So this becomes 1 over 11 times 4, negative 1, 3, 2, times 19, negative 7. So when you scalar multiply, I'm going to get 4 over 11, 3 over 11, negative 1 over 11, and 2 over 11. And I'm going to multiply by 19, negative 7. Now remember, it's row by column. So 4 times 19 plus 3 times negative 7, and these are both over 11. So that's row 1 by column 1. Oh, remember, this is a 2 by 2. I'm going to multiply by a 2 by 1. So my result is going to be a 2 by 1 matrix. So 2 rows, 1 column. That's going to be my x, y. That's what I'm solving for. 2 rows, 1 column. So there's my first element, row by column, and then my second element will be negative 1 times negative 7 over 11 plus, negative 1 times 19, row by column, plus 2 times negative 7 over 11, and I'm just going to work horizontally here because I'm running out of space. 4 times 19 is 76 minus 21 all over 11, and this is negative 19 plus a negative 14 is negative 33, right? Negative 19 minus 14 all over 11. So this is a nice number. 55 over 11 is 5. Negative 33 over 11 is negative 3. So my solution to this system must be 5, negative 3. 2 times 5 is 10, plus 9 is 19, that checks. 5 minus 12 is negative 7, that checks. Now, what makes this useful is a 3 by, when I have a system of equations 3 by 3. So let's see how we would do this on the calculator. All right, so matrix. So I'm going to edit matrix A, and it's going to be a 2 by 2. And my system was 2, negative 3, 1, 4. And then I want to edit matrix B, and that was the constant matrix, so that was a 2 by 1. And that was just 19, negative 7. And then I can call up, actually, daggone it. That happens. So that was negative 7. I never hit enter to get out of that, so I have to second quit. So I'm going to go second matrix, and I'm going to call up matrix A, but I'm going to take its inverse, and then I'm going to multiply by matrix B. And what did I get? 5, negative 3. So you can imagine if you had a 3-variable system, for example, if you had 3x minus 2y plus 1z equals 10, and 1/2 x plus 5y minus 10z equal 12, and negative x plus 3y plus 6z equaled negative 5. If you had a system like that, it'd be very easy to set it up as a matrix. Whoops. Here's your A, here's your unknown, here's your B, where this would be 3, negative 2, 1, 1/2, 5, negative 10, negative 1, 3, 6. There'd be your matrix A. You don't know your matrix X. Your matrix B would just be 10, 12, negative 5. And then in your calculator, X would just be the inverse of A times B. So then it gets slick when you have a lot of variables, which is what goes on in the real world. Solving systems by inverse matrices.